Good evening. In this session, let us discuss about equations of motion in case of freely falling body. In general, equations of motion are, what are the equations of motion in general? V is u plus at, S is equal to ut plus half at square, V square minus u square is 2as, Sn is equal to u plus a by 2 into 2n minus 1. All these equations of motion are applicable only to the case where acceleration is uniform. Acceleration must be constant, only then these equations of motion are applicable. Here u is the initial velocity, a is uniform acceleration of the body, v is velocity at the end of time t, s is the displacement in time t, Sn is the displacement in nth second. That particular nth second displacement is called Sn. Now, in case of a freely falling body, initial velocity is 0. When a body is dropped, its initial velocity is 0. It acquires velocity because of gravitational force. So, acceleration of a freely falling body due to gravitational force is called acceleration due to gravity. Acceleration of a freely falling body due to gravitational force is called acceleration due to gravity. A is equal to g. So, in case of a freely falling body, u is equal to 0, a is equal to g. The value of g is 9.8 meter per second square. It slightly varies from place to place. If the value of g is not given in the problems, we take it as 9.8 meter per second square. In some cases, they give g approximately as 10 meter per second square, then we substitute that value for the calculation. Right? Now, applying these two conditions in the equation, velocity at the end of time t, v is u plus at, u is equal to 0, a is equal to g. So, v is equal to gt. Now, in the second equation, displacement at the end of time t, u0, this term becomes 0, so it is just half, a is g here, half gt square. Coming to the third equation, v square, u is 0 is equal to 2, a is g, s. And coming to the fourth equation, Sn is equal to u0, a is g, g by 2 into 2n minus 1. These are the equations of motion in case of freely falling body. Just we have substituted u as 0 and a as g here. That's it. Now, the interesting thing, suppose from this implies v proportional to t, because g is constant, so v is proportional to t. So, what is the ratio of velocities at the end of 1 second, at the end of 2 seconds, 3 seconds, so on? In case of a freely falling body, it is just 1:2:3:4 because v proportional to t. Okay. Now, you have to answer this. From this, as g by 2 is constant, s is proportional to t square. You have to answer this question. What is the ratio of displacements at the end of 1 second, 2 seconds, 3 seconds, 4 seconds, so on? So, if you substitute t as 1, t square becomes 1 in 2 seconds. So, substitute t as 2, it becomes 2 square. T has 3, it becomes 3 square. So, 1:4:9:16:25 and so on. Ratio of displacements in 1 second, in 2 seconds, in 3 seconds of a freely falling body. Now, from this equation, V square proportional to S or V proportional to root S. From this, a question can be asked like this. What is the ratio of velocities at the end of 1 meter, at the end of 2 meters travel, at the end of 3 meters travel from the initial point? So, V proportional to root S at the end of 1 meter 1, at the end of 2 meters root 2, at the end of 3 meters root 3, and so on, right? And from this expression, Sn is proportional to, as G by 2 is constant, Sn is proportional to 2n minus 1 implies the ratio of displacements in the first second, second second, third second, fourth second, and so on, or ratio of displacements of a freely falling body in successive equal time intervals. See here, if you take n as 1, 2 minus 1, 1. N as 2, 2 2s are 4 minus 1. N as 3, it is 5. 1 is to 3 is to 5 is to 7, and so on. Okay, that is the ratio of displacements at the end in successive equal time intervals. Okay, and here there are certain things you have to answer the questions strategically to save time in the competitive examinations. See, from this I will tell you one interesting concept. Look here. So, from these two equations, from this equation and from this equation, ratio of displacements in time t and in the nth second is equal to half gt square by half 2n minus 1. So, it becomes t square by 2n minus 1. Ratio of displacements of a freely falling body in time t and in the nth second is S by Sn is equal to t square by 2n minus 1. Look here, if n is the last second of the free fall, n is the last second of free fall, then t is equal to n, isn't it? Suppose if the last second of free fall is 10th second, total time of free fall will be 10 seconds. Got the point? If the last second of free fall is 10th second, total time of free fall is 10 seconds, or vice versa. If total time of free fall is 10 seconds, last second becomes 10th second. So, if n is the last second of free fall, then t is equal to n. So, if you substitute t is equal to n here, it implies S by Sn is equal to n square by 2n minus 1. This is a very important formula we will be using in solving problems in case of a freely falling body. Okay. So, here just these are the equations of motion. In particular, in case of free fall, u is equal to 0, a is equal to g. That is it. So, I will give you one problem. You have to answer all the questions given on that problem, right? Now, note down the problem. A body is dropped. A body is dropped from a height 78.4 meters. Find its velocity on reaching the ground. Its velocity on reaching the ground and time of free fall. Time of free fall. So, a body is dropped from a height 78.4 meters. Find its velocity on reaching the ground and also time of free fall. Look here. So, just we need to note down the data. A body is dropped, u is equal to 0, a is equal to g, and we take g as 9.8 meter per second square. On reaching the ground, find the time of free fall. So, a body is dropped from this point and reaches the ground. Okay, starting point is a final point. This is at a height of 78.4 meters. On reaching the ground, its displacement is s is equal to the height from which it is dropped. In the first question, what is its velocity on reaching the ground? So, I just noted down the data. A body is dropped, implies u is equal to 0, a is equal to g, we take g value as 9.8 meter per second square. From a height h, so height is given. On reaching the ground, displacement is nothing but the height from which it is dropped. What is its velocity on reaching the ground? What equation connects them? V square minus u square is equal to 2as. V square minus u is 0 is equal to 2as. From this, v is equal to square root of 2gh. So, suppose if you practice the problems, that formula we can directly write. When in case of a body dropped from a height h, velocity on reaching the ground is square root of 2gh. So, just substitute that here. V is equal to square root of 2, g is 9.8 and h is 78.4. So, this is 2, 9.8, 9.8, 8s are 78.4. So, we are writing it as 9.8 into 8. See, 9.8 square under square root, 9.8. 2 8s are 16 under square root, 4. So, it is 39.2 meter per second. Velocity on reaching the ground is 39.2 meter per second. Right, that is the first thing. And time of free fall you need to find. Again, u is equal to 0, a is equal to g, s is equal to h. What is the time of free fall? What equation connects them? Displacement in time t is s is ut plus half at square. Here free fall case half gt square, from which t is equal to square root of 2 s by g, but s is equal to h, so square root of 2h by g. Majority of the students, if I ask the question in the class, they just shout like anything. Velocity on reaching the ground, root 2gh. Time of free fall, square root of 2h by g. So, if you can directly come to this formula, t is equal to square root of 2, 78.4 h by g. 9.8 gets cancelled 8 times, 2 into 8, 16 under root. So, t is equal to 4 seconds. T is equal to 4 seconds. Is it clear? So, that is the time of free fall. So, this is one example. Next, note down another example. Just knowing the equations, you can do any problems in this topic. So, look here. A freely falling body, covers covers 9/25 of the total distance in the last second. In the last second. Find 1. Total time taken, total time of free fall 2, height of free fall 3, displacement in the last second 4, velocity on reaching the ground. Okay, so a freely falling body covers 9/25 of the total distance in the last second. Find time of free fall, height from which it is dropped, displacement in the last second and velocity on reaching the ground. In the question, G is given as 10 meter per second square. So, let us try to solve this problem. Look here, a freely falling body covers 9/25 of the total distance. If you remember the synopsis, we can directly go to the formula S by Sn is equal to n square by 2n minus 1. See here, displacement in time t is half gt square, displacement in the nth second is g by 2 into 2n minus 1, from which S by Sn is equal to t square by 2n minus 1. If n is the last second, then t is equal to n implies S by Sn is equal to n square by 2n minus 1. This already we learnt it. Okay. So, here okay, S by Sn is equal to n square by 2n minus 1. Now, coming to this, S by Sn is equal to n square by 2n minus 1. Here, what is given? A body covers 9/25 of the total distance in the last second. Yes, n is given as 9/25 s. From this, applying cross multiplication, if you bring this to that side, S by Sn is equal to 25 by 9. But from this equation, S by Sn is n square by 2n minus 1. N square by 2n minus 1 is 25 by 9. If you just apply cross multiplication, you get a quadratic equation. On solving that equation, you can find n, from which you can find out the total time. But let us take a trial solution. Look here very carefully. You need not apply cross multiplication, nothing. N, we are just taking a trial solution. If it works out, we can save a lot of time. N square is 25. What is n? N is equal to 5. Suppose if you substitute n as 5 here, 2 into 5 minus 1, 10 minus 1, 9. So, if n is equal to 5, it is satisfying. N square is 25, 2n minus 1 is 9. So, n is equal to 5 is the right trial. So, last second is the nth second. Total time of free fall is nothing but 5 seconds. That's it. So, time of free fall is done. Next, you need to find out height. So, height of free fall, S is equal to half gt square. So, half g is given as 10, t is 5, t square is 25. So, 5 25s 125 meters. So, height from which the body is dropped is 125 meters. Next, you are supposed to find displacement in the last second. So, Sn is equal to g by 2 into 2n minus 1. So, Sn is equal to g by 2, 10 by 2 is 5, 2, last second is the 5th second minus 1. So, 5, 2 5s are 10 minus 1, so it is Sn is equal to 45 meters. So, displacement in the last second is 45 meters. You find out velocity on reaching the ground. Yes, V is equal to gt in time t. So, V is equal to 10 into time is 5 seconds. So, velocity on reaching the ground is 50 meter per second. 50 meter per second. So, that is velocity on reaching the ground in this case. Okay. So, just in case of problems, in case of a freely falling body, u is equal to 0, a is equal to g, all equations of motion are as it is. V is gt, s is half gt square, v square is 2gs, Sn is equal to g by 2 into 2n minus 1. S by Sn is t square by 2n minus 1 in case of free fall. If n is the last second, S by Sn is equal to n square by 2n minus 1. Is it okay? So, that is about this problem. Now, let us go to vertical projection. So, let us see vertical projection or a body projected, in case of a body vertically projected up, we will see what happens. Vertical projection. Right. Okay. So, let us see vertical projection. A body is projected vertically up with a velocity u. So, here from this point A, a body is projected vertically up with a velocity u. So, initial velocity is u. What is its acceleration? Body is moving up, but its acceleration is acceleration due to gravity, which acts in the downward direction. We know when a body is in air, whether it is moving up or down or horizontal does not matter, acceleration due to gravity always acts in the downward, gravitational force always acts in the vertically downward direction. So, acceleration due to gravity is always in the vertically downward direction. In this particular case, acceleration u is equal to u. Acceleration is minus g. Why we have taken that negative sign? See, velocity and acceleration are vectors. Velocity direction is upwards, acceleration direction is downwards. So, as it is in the opposite direction, acceleration is given a negative sign. Negative acceleration is retardation. I told you, in case of retardation, the speed of the body decreases with time. Exactly, that is what happens. When a body is projected vertically up, its retardation, that is braking, is in the downward direction. So, as it moves up, its velocity keeps on decreasing and finally becomes 0. When it becomes 0, it cannot go beyond that, just it starts falling down. So, at the highest point, its velocity becomes equal to 0. So, you have to visualize that. When a body is projected vertically up, it goes straight, reaches a maximum height and then it falls back. So, here coming to the equations of motion. Equations of motion. See here, V is equal to u minus gt, u plus at in place of a minus g. S is equal to ut minus half gt square. V square minus u square is equal to minus 2gs. Sn is equal to u minus g by 2 into 2n minus 1. So, in case of vertical projection, u is equal to u, a is equal to minus g. So, those are the equations of motion. Now we are going to see the case where the body reaches the maximum height. At the highest point, V is equal to 0. So, implies from this equation 0 is equal to u minus gt. This implies gt is equal to u or t is equal to u by g. What is this t? That is the time taken by the vertically projected body to reach the maximum height. So, carefully. So, a body is projected vertically up. Here this t is time taken by the body to reach the maximum height. We call it as time of ascent. So, in case of vertical projection, time of ascent, time taken to reach the highest point is u by g. That is 1. Coming to the second equation, S is ut minus half gt square. There is no v term, no relevance. Coming to the third equation, v square is 0 minus u square is minus 2gh. At the highest point, suppose if you project a body here, reaches the highest point h, that is the height of the point. So, from this point to the highest point, displacement is nothing but the maximum height reached. So, minus u square is minus 2gh. It implies maximum height reached by a vertically projected body is u square by 2g. Is it okay? So, at the maximum height, v is equal to 0, from which we could prove time of ascent is u by g, maximum height reached is u square by 2g. Is it all right? Okay. Now, look here. We are going to prove that in case of a body projected vertically up, time of ascent is equal to time of descent. First, its speed on reaching the ground is same as that of projection, because in all these cases we are ignoring air resistance. So, it comes back or returns to the ground with the same speed as that of projection. So, time of ascent is time of descent, speed on reaching the ground is same as that of projection. See here. So, a body is projected vertically up with a velocity u, reaches a maximum height h and again comes back. So, look here. When a body is projected vertically up, at the highest point v is equal to 0, s is equal to h, a is equal to minus g, v square minus u square is equal to minus 2gh. So, h is equal to u square by 2g. Actually, in the previous page, we proved it already. Maximum height reached by a vertically projected body is u square by 2g. That is what again I proved it. Now, similarly, time of ascent is proved as u by g. So, in case of a body projected vertically up with a velocity u, maximum height reached is u square by 2g, time of ascent is u by g. That is already derived. Now, we are going to prove time of ascent is equal to time of descent. Time of ascent is equal to time of descent. Look here. We want to find the time of descent. See, body is projected vertically up from the point A, reach the highest point B, okay, and again it comes back. Let us consider the journey from B to A, highest, that is we are considering the return journey of it. So, if you consider B to A, as this is the highest point, or as it is dropping freely, its initial velocity is 0. A is equal to G. S is equal to H, which was the maximum height reached by it, that is equal to U square by 2G. We already proved that, because S is equal to H implies S is equal to U square by 2G. What is the time taken to reach the point A? So, B to A, we are finding out the time. The time of that is nothing but the time of descent. What equation connects them? S is equal to ut plus half at square implies U square by 2G. Yes, U is 0, half G T square. So, if you apply cross multiplication, T square is equal to U square by 2G into 2 by G. This and this gets cancelled, implies T square is equal to U square by G square. U square by G square implies T is equal to U by G. This is nothing but time of descent, implies time of ascent and time of descent are equal in case of a vertically projected body, that is equal to U by G. Then time of flight, it is the time spent by the body in air during its projection. So, here time of flight is nothing but time of ascent plus time of descent, that is 2U by G, U by G plus U by G. So, it is 2U by G, that is the time of flight. Okay? Now, the next thing we want to prove is it reaches the ground or it returns to the ground with the same speed as that of projection. So, here let us consider its journey downwards, that is from B to A. So, if you consider the journey from B to A, U is equal to 0, A is equal to G, S is equal to H, that is U square by 2G. What is its final velocity? What is its velocity on reaching the ground? What equation connects them? Yes, V square minus U square is equal to 2AS, implies V square is equal to 2, A is G, S is U square by 2G. This and this gets cancelled. V square is equal to U square, V is equal to plus or minus U. Now, look here, body is projected vertically up, but it reached the ground with a velocity V downwards. As its direction is opposite, we say V is equal to minus U. Okay? It reaches the ground with the same speed of projection, but in a direction opposite to that of projection. So, velocity V is minus U. What is its speed? Speed being a scalar, it is enough to mention the magnitude. So, what is its speed? Then speed is equal to U. What is its velocity on reaching the ground? If velocity of projection is U, then velocity on reaching the ground becomes equal to minus U. So, here in this case what we have proved is, in case of a body projected vertically up, let us recall all the formulae. In case of a body projected vertically up with a velocity U, time of ascent is equal to time of descent is equal to U by G. Time spent by it in air or time of flight is 2U by G. Maximum height reached by the vertically projected body is U square by 2G. It reaches the ground with the same velocity of projection. This is the case of vertical projection. Okay. Similarly, in case of free fall from a height h On reaching the ground, velocity is square root of 2gh. Time taken to reach the ground, square root of 2h by g. Just these formulae, v square is 2as, v is root 2gh. S is half gt square, from which t is equal to square root of 2h by g. And also in case of free fall, S by Sn is equal to t square by 2n minus 1. If t is the last second, S by Sn is equal to n square by 2n minus 1. Okay, so those are the shortcut formulae we have learned in case of free fall and vertical projection. I think I am clear. So, I will continue with the next topic, that is vertical projection from the top of a tower. After that, we do the problems based on motion in a straight line. Okay, I will stop here for today. Thank you and bye-bye.